The gold you're wearing right now should not exist. By every law of physics we have, it's impossible. No ordinary star in the entire universe is powerful enough to forge it. Look down at that ring, that chain, that watch, even the filling in your tooth. For decades, scientists could explain where almost every element in existence came from, except that one. The gold on your finger was a genuine cosmic mystery, a furnace nobody could find. And when we finally cracked it, the answer turned out to be one of the most violent, most beautiful catastrophes the universe is capable of. Your jewelry isn't just old. It's the shrapnel of an explosion that briefly outshone an entire galaxy. So today we're tracing the impossible birth of gold. We'll cover why even our own sun could never make it, the graveyard of dead stars where the real forge is hidden, the few insane seconds in which gold is actually assembled, and the night in 2017 when humanity finally caught the cosmic gold factory in the act. Stick around, because by the end, you will never look at a wedding ring the same way again. Start with how stars make elements at all, because it's basically cosmic cooking. A star like our sun spends its life fusing lightweight atoms into heavier ones. Hydrogen into helium, and in bigger stars, helium into carbon, oxygen, neon, and on up the ladder. Every fusion step releases energy, which is exactly what makes a star shine. It's a furnace that pays for itself. But there is a hard ceiling, and its name is iron. When a star tries to fuse iron into something heavier, the whole deal flips. Instead of releasing energy, fusion suddenly starts costing energy. Iron is the point where the furnace stops paying out and starts charging emission. So fusion just stops. Every element lighter than iron, a star can forge in its core. But gold sits far, far past iron on the periodic table. To a normal star, gold isn't merely hard to make. It's forbidden. The same furnace that built the calcium in your bones and the iron in your blood simply cannot build a ring on your finger. So if stars can't make gold, and gold obviously exists, then something out there is doing the impossible. And to find it, you have to go looking in a graveyard. When a truly massive star dies, it doesn't just quietly fade out. It collapses and detonates as a supernova. And what it leaves behind is one of the strangest objects in all of nature, a neutron star. Take everything you think you know about density and throw it out the window. A neutron star crams more mass than our entire sun into a ball the size of a city, roughly 20 kilometers across. It is so dense that a single teaspoon of it would weigh about 1 billion tons. Its gravity is so brutal that it has crushed protons and electrons together into pure neutrons. The very same particles that, when packed loosely inside an atom, are the key ingredient we've been missing this whole time. Now here's where it gets cinematic. Sometimes two of these neutron stars are born orbiting each other, a binary pair. And over millions of years, they slowly spiral inward, closer and closer, locked in a gravitational death spiral, bleeding away their energy as ripples in space-time itself, until they're about to do something the universe very rarely gets to do. And then they touch. Two dead stars, each heavier than our sun, slam into one another at a sizable fraction of the speed of light. This is a kilonova, and in that instant the universe performs the most violent alchemy there is. The collision shatters both neutron stars and blasts out a colossal cloud of their guts. And that cloud is unimaginably rich in free neutrons, the exact ingredient a normal star never has lying around. In the chaos, atomic nuclei get bombarded by so many neutrons so fast that they simply cannot keep up. Normally, a nucleus that swallows too many neutrons turns unstable and falls apart. But here, neutrons are hammering in faster than the nucleus can decay. The atoms are forced to gorge, packing on neutron after neutron in less than a second, building up into heavier and heavier elements. Scientists call this the R process, short for rapid neutron capture. It is the universe brute forcing its way straight past the iron ceiling. And in just a few seconds of this madness, a single collision forges more gold than the entire mass of the Earth. Not a mine's worth, not a country's worth, whole planet's worth of gold, made in seconds. Now pause and ask yourself the obvious question. How could anyone possibly know any of this? It's a beautiful story, sure, but it supposedly happened who knows where, unimaginably far away. We can't exactly fly out and check. Hold that skepticism tight, because in 2017, the universe handed us the receipt. On August 17th, 2017, detectors here on Earth felt something they had never confirmed before, a tremor in the fabric of space-time itself, a gravitational wave, rolling in from about 130 million light-years away. This particular ripple carried a very specific fingerprint, the frantic final spiral of two neutron stars whirling together and merging. And then, for the first time ever, telescopes swung around and actually saw the aftermath glowing in the exact same spot, a kilonova, lighting up precisely where the gravitational waves had come from. When astronomers split that light into its spectrum, there it was, the chemical signature of freshly forged heavy elements, the very metals the R process was supposed to make. We didn't just theorize the cosmic gold factory. We caught it running. Two dead stars collided, and we watched them mint a treasure of heavy metal in real time. It's worth being honest that scientists still debate whether these mergers make all the gold or whether other rare events chip in too. But the crime scene, the smoking gun, the actual forge, we have finally seen it with our own instruments. So here's the journey your gold actually took. Long before the sun even existed, somewhere in our galaxy, two neutron stars collided and flung their newly minted gold out into space. That gold drifted for ages, slowly mixing into a vast cloud of gas and dust. Then about 4.5 billion years ago, that enriched cloud collapsed to form our sun, our planets, and the raw material of Earth, gold already baked in from the start. Every gold atom on this planet is older than the planet itself, delivered here as a hand-me-down from a catastrophe that happened before our world was even born. And the reason gold is so rare, so expensive, so fought over throughout history, is beautifully simple. Neutron stars almost never collide. Gold is precious not because it's shiny, but because the only thing in the universe that makes it is one of the rarest events in the cosmos. So the next time you see a gold ring, understand what you are actually looking at. That is not just a pretty metal. It is a physical fragment of a collision between two dead stars, an event so violent it warped space-time, so bright it briefly outshone its entire galaxy, so rare that the universe only manages it once in a great, while across billions upon billions of stars. You are wearing the debris of a cosmic explosion, cooled and polished and slipped onto a finger. The most romantic object we own, the wedding ring, is quite literally a relic of one of the most destructive things that can ever happen in the universe. So no, the gold you're wearing shouldn't exist. Not by the ordinary rules, and not from any normal star. It exists because, somewhere out there, long ago, two impossible objects found each other, spiraled together, and died in a single flash of violent alchemy that made the unmakeable. Every ounce of it is a souvenir from a catastrophe you will never see, older than the ground beneath your feet, forged in a few seconds of chaos that outshone 100 billion suns. You're not just wearing gold. You're wearing the ashes of a cosmic collision, and now you know its name.